Machines and their layout. We will be discussing the type of machines which are used in Brodom line and how these machines are arranged. Type of machines in Brodom. First, opening machines are there, where the main job of these machines is to open out the tufts. So, there are two things about opening. One is breaking apart, that is, we break the bigger tuft into smaller ones, or we increase the volume of the tufts. Both are happening. Also, the third possibility could be a change in shape of the tufts. So, we have opening machines, then we have mixing machines, where we mix the fibers. Then we have cleaning machines in the Brodom line, we have dust removing equipments also in the Brodom line. So, these are the type of machines which are there in the Brodom. So, Brodom is not a single machine, there is a set of machines and the machines are linked together with each other, and broadly we can classify the machines into 4 groups: opening, mixing, cleaning, dust removing machines. Now, before we take up those machines, let us first try to understand some general consideration regarding opening and cleaning. Opening and cleaning, these two generally go together. Opening of a cotton tuft by single machine to the desired level is not advisable, as it will lead to considerable stress on fibers, leading to damage. But if we try to open or break a large chunk of fiber into a very small size tuft in one step, in that case there will be tremendous amount of stress which will act on the fibers, and the fibers may get damaged, and therefore, this should not be tried. This should not be, and hence it is not done also. The intensity of the opening and cleaning process should increase progressively. In order to avoid damage, therefore, what we should do? Now, we know what is our target size of the tufts. So, we want to reach that target size not in one go or one step, but we go through a series of steps, and that is why the intensity of the opening and cleaning processes should increase progressively. Initial machines have to act on large compressed tufts and hence should be gentle in nature on the tufts, because when the tufts come in the form of a bale, there is a lot of pressure on them. We have discussed that, and the density of the tuft is quite high, and therefore, aggressive action should not take place on these compressed tufts. So, the initially it should be gentle in nature. Dirt can be removed from the tuft surface, that we have to remember. If the trash particle is inside the tuft, we will not be able to remove it, it will remain trapped. So, only the particles which are there on the surface of a tuft can only be removed. Hence, new surfaces must be continuously generated. The form of opening machine must therefore be adapted to the degree of opening already achieved. So, what we should do, that the machine should be designed in such a way that it will keep on generating new surfaces. So, whenever I break a tuft into two pieces, I generate two new surfaces. We have to see that as the tuft go from one particular machine to another machine, we must generate lot of new surfaces, because on the trash particles are available on the surface of the tuft, then only these particles can be removed, liberated and removed easily. So, this is important. The other thing is, newly created surface should be cleaned as fast as possible, so that the dust do not deposit on the tufts. A dust means not only dust, it could be trash also. This means each opening step should be followed by a cleaning step without intervening transport. That means opening and cleaning should go together. That is what it should be. Otherwise, as I have told also, that there is a chance of remixing. The degree of cleaning is linearly dependent on the degree of opening. So, this is also important, that if the opening is better, that means I have generated lot of new surfaces, and therefore, there is a chance of better cleaning. Ideally, opening and cleaning machine should form a unit. So, you will find as we discuss the machines in some future lectures, you will find that most of these machines which have been designed, you will find that both opening and cleaning are happening together, barring few machines. Now, opening zones in blow room. In this slide, the entire blow room line, if we look at it, we can find the following operating zones in blow room, and these are, the first one is opening zone, this followed by coarse cleaning zone, then blending or mixing zone, then fine cleaning zone, then intensive cleaning zone, then card feed arrangement or lap formations. So, the entire line consists of these zones: opening, then cleaning, blending or mixing if we want, followed by fine cleaning and intensive cleaning, or it could be just one of them, this is possible. After that, either we should go for lap formations or feeding of the material, that is card feed arrangement. Dust removal is accomplished in each blow room machine to some extent, because every time we are handling the tufts, there is a scope for the dust to be liberated also, other than the trash particles. So, inside the machines, if we look at it, we will find it is full of dust laden air, and hence if we keep the machine under negative pressure, then that is connecting the machine to a suction source, then this dust laden air can be taken out. So, a lot of dust can also be removed from each of those machines, and maintain a negative pressure also helps in a way that from the environment the air will enter to the machines. There is no way for the air to escape, the dust laden air will not escape to the outside of the machine. So, hence the possibilities of contamination, contaminating the surrounding air will be less if the machines are kept under negative pressures, with the chamber of the machines. Special dust removing equipments are also available. whatever dust is liberated in each of those machines, part of it is removed, entire dust we will not be able to remove it, because process has to be quite fast. In that case, so much of dust cannot be removed, some of it still remains, or if you try to remove it, maybe lot of fibers also will be losing in the process, and hence some dust will anyway pass through all the machines, and it will go to the next process also. And today there are some dust removal equipment which are there. There are some machines are specifically designed to take care of the dust part only. So, we will discuss them. Okay. So, zone 1, say we have said that this is basically opening zone, and some of the machines which are used here, automatic bell opening machines, bell breakers, blenders, these are the machines which are used. We will learn about those machines in some other lecture, but these are the names of the machines in the opening zone, and their main function is to open the material gently. So, they should be very mild in action. The design of this machine should be such that they should be very mild in actions, open up to smaller flocks without damaging the fibers, form flocks of equal size as far as possible. Flocks should be small, if smaller the flock size better it is, and blend material in the form of tufts right at the start of the process. If we can blend or if we can mix the tufts, that also is the objective here. Some kind of mixing also happens in these machines. The shortcomings are, these machines are not good cleaner due to very high throughput. So, these machines are not very good cleaner because the throughput is very, very high, because they have been designed only to break large chunk of material into smaller pieces. So, that is their main objective, and they are mild in nature as far as their opening action is concerned. Hence, they will not be good cleaner. The next set of machines which are used called coarse cleaning machines. The name itself shows that the cleaning is not very intense here, and the type of machine, their names are step cleaner, Exipro cleaner, monocylinder cleaner. These are the some machines which are used in zone 2. The objective is to clean the liberated trash generated by the previous machines. That is, the trash that has been liberated in the previous machine, that is by the bell opening equipments, when they are handling large tufts or large chunk of material, lot of trash must have been liberated. Now, in these machines we try to actually clean the tufts. The shortcomings of this machine is the opening effect is relatively small, since adequate surface area has already been generated prior to this process. So, in the previous process you have already broken the large tufts into small pieces already. So, here we do not really need very aggressive action on the tuft. Our main purpose will be to clean the surface of the tufts. That is the main purpose, and accordingly these machines have been designed. So, the design feature is the material is treated by revolving strikers or fingers in free flight. So, they are floating, the tufts are floating in air and the striking elements are hitting them, and that is how the machines is going to work on the tufts. The striking elements are widely spaced on a revolving drum and the stress extraction through the grid bursts under the machine. So, these are the common design feature of these machines, tape cleaner, Exipro cleaner or monocylinder cleaner. We will discuss these machines in future. From here we go to the mixing and blending machines, which is called zone 3. So, once we have produced small tufts and then we have cleaned them to some extent, now we want to mix these tufts, or if we want to blend, we can also blend them. Blending is done when the fibers are of two different natures. Otherwise, if the fibers of similar in nature, then we call it is a mixing process. So, the machines are multi-mixer, unimix, aeromix. So, different companies have given different names, but the basic principles of working is same, and we will study in some other lecture. Objective of these machines is to mix the tufts belonging to different bales, so that there is a consistency in the properties of the product that we make, that is the properties of the yarn. There will be some variation in the quality parameters of fibers coming from different bales, and if we can mix them properly, then the quality parameters of the yarn will be much more consistent, and hence mixing equipments are necessary in the blow room line. They also act as a reservoir of material. This is also important, that we store the material within this. So, they also act as a reservoir. We will discuss about them in more details. So, these two are the objectives, and if we look at the design features of these machines, several large vertical trunks or vertical chutes are there to hold the material in the form of column, and we remove the material from the base. So, we create vertical columns of material, maybe 6 columns or 8 columns, and then we remove the material from the base. This is the typical design feature of the machines. The shortcoming is that there is no cleaning possibility here. So, these machines have been designed specifically for mixing purpose and to act as a reservoir of material. So, there is no cleaning action, there is no opening action here. It acts as a storage space within the line, and at the same time it also try to mix the tufts. Then zone 5 machines, one typical machine is RN cleaner, also we will discuss about them. The objective is to create new surfaces of the tufts for further cleaning through vigorous opening action. So, we have already cleaned the tufts in the coarse cleaning equipments. Now, we are going to fine cleaning equipments. The name itself implies that now these equipments should be designed in such a way that they will be little bit more aggressive on the tufts, so that we create new surfaces. Some cleaning has already been done. Now, if we want to clean it further, we have to create new surface and then we have to clean it. So, as the tufts become smaller and smaller in size, we have to be more and more aggressive on them in order to break them into pieces and thereby creating new surfaces. Once we create new surface, then only the trash particles will be exposed. So, design feature is clamp feed arrangements are used in these machines. Tufts are fed slowly in the beater chamber and beaten by blades. Reduce spacing between striker elements in order to accommodate more strikers. Trash extraction through grid bars under the machines. So, typical design feature of the machines which are used here will be like this. Always this clamp feed is something which you should remember here, that is what is very important. Then comes intensive cleaning, that is these cleaning machines are much more intensive in nature than the previous one. Sometimes zone 4, zone 5 machines are same, that is some machines can act, we can have only one zone, zone 4, zone 5, instead of having zone 4, zone 5 we can just have one zone and we can have intensive cleaning units which will serve the purpose of the fine cleaning and intensive cleaning also. So, some machines and their names are given here like Kirschner beater, cleaner, CBT1, CBT3, CBT4, these are commercial names of the company called Tuzler. Then we have CNT1, CNT3, then we have ERM cleaner. So, these are different types of machines made by different companies, and but their basic design features we are going to discuss now, that they have a clamp feed arrangement for tufts and sometimes they may having pedal feed arrangement also. Both of them are available. Tufts are fed slowly in the beater chamber and teased by needles, pins or blades, saw teeth. So, now what happens, as we want to have intensive cleaning actions, two things are changing. One is the way we grip the material, where a clamp feed or sometimes a pedal feed also could be used, or both are possible. So, that idea is that we should be able to grip the tufts properly, so that they do not slip from the nipping point. Nipping point has to be made more and more powerful, otherwise the tufts may slip. And the second thing is that the striking elements have to be smaller in size, because the tufts have become smaller now. So, if we have to break those tufts further, then we should think of going for a kind of teasing action. We have discussed about teasing action earlier. So, teasing action, if we want, then we need either needles, pins, saw teeth. This is what is required. So, all these cleaners that we will see will be having such kind of striking elements on their surface, and the trash is always extracted through the grid bars under the beater chamber. It will create new surfaces for further cleaning through very vigorous opening actions. So, as we start with very large tufts, we break them, make them little smaller, clean them, mix them, again make them smaller. This is how the process is carried out. And the last zone is card feed zones, that is we have to now clean the tufts in the blow room. Now, this has become relatively clean tufts which are small in size, and now they are suitable. If we have to go for further cleaning, we have to go to a different machines, and the name of that machine is carding machine. So, you learn about the carding machine also in this course. So, now the card feed arrangements, there are two types of machines which are there. One is called scratcher, another one is chute feed or continuous feed. So, now the scotcher, what we do? We produce an uniform lap, or we have to produce a thick mat of fibers suitable for card feed. So, now either we produce a lap is basically a thick sheet of cotton tufts of a certain length, which is suitable for feeding to a carding machines. So, this is an old practice where scotcher used to be there and used to form these laps. Most of the time the blowrooms will be directly connected through a chute feed system to the carding machines. So, a set of cards will be connected to the blowroom, so that we can continuously feed the tufts to the carding machine. So, it is also known as chute feed system or continuous feed system. Lap feed is discontinuous in nature, because you produce the laps, we will learn about them in more details, and the laps are stored, and then the laps are transported to the carding machines, and then the laps are potted on the carding machine. So, it is basically scotcher is used to produce laps, and this process is a discontinuous process. Whereas, if I connect the blowroom directly to the carding machines, and we say it is chute feed system or continuous feed system, and it is a continuous operation. Now, design feature of the scotcher is the deposition of the tufts on cages with internal suction, and as I deposit the tufts on the cage, it becomes a sheet. Then consolidation of the deposited tufts in the sheet form. Sheet has already formed because tufts are coming and falling on a cage. A cage is basically a perforated drum. We will know about them, we will learn about them in more details, and then it has to be consolidated, otherwise it is very floppy. So, we have to compress it and then roll it in the form of a sheet, roll the sheet to a particular prefixed length, and it becomes cylindrical in shape. That is what the design feature of the scotcher is like this. And on the chute feed system, we have pneumatic transportation of tufts, then deposition of the tufts into vertical rectangular chute, maintaining the height of the tufts in the chute. We are basically making a column of tufts behind the carding machines. So, in these columns we are depositing the tufts, and a vertical column of tufts is created, then delivering the tufts to the card feed system. So, from that chute where there is a column of tuft, we have to now feed this column of tufts to the card feed system. That is what is the design feature of the chute feed system, and we will learn about them in more details. So, these are the different zones. There are 6 zones we have discussed here. The other thing which is there in the blowroom line is dust removal. The name of the machines are dust extractor, all the cages which are there, which also can remove some dust. Then there are dust remover separately, could be some machines are there. So, they have been specifically designed to remove dust from the tufts. Design feature is separating particles directly from the fiber surface by suction or by scraping. That is how dust particles are separated from the fiber surface, mostly by suction system. So, whenever the material is rolled or beaten or thrown out, the dust particles are released and they are sucked away by some suction system. Releasing dust into the air and then removal of dust laden air. The other thing could be that we release the dust into the air and then remove the dust from the dust laden air. We will discuss about this type of machines which are there. The direct or indirect means of dust removal is by using perforated drum, stationary perforated surface, circulating perforated belt can be used, or stationary comb can be used. All of them will be liberate the dust particles and also will be able to suck them out. So, we have to, whenever we have to deal with the dust only, the dust being very smaller in size, they are difficult to remove. So, we have to have controlled suction, and we have to also see how to liberate them. For liberation, we need some kind of friction between the fiber and metallic surface, and once they are liberated, they have to be sucked away with the help of controlled suction. With that, we close this session and thank you.